So welcome everybody to this latest video on 162 Maths, and in this video we'll be focusing on how to work out the surface area of spheres and cones. Now if you've watched the previous video looking at surface area of 3D shapes, then you'll understand that the surface area is the total area of the net of the shape. Now when we move on to spheres and cones, then trying to envisage what the net of a sphere and cone look like is a little bit more difficult because it's not more of a traditional prism. Now the net of a cone are hard to picture due to the fact that they've got this curve element of their shape. So to work out its surface area, basically you kind of need to know the formula and revise it like a spelling test. Now looking at the properties of a sphere, then more often than not you'll either be given the radius or the diameter, and the formula for the surface area of a sphere is 4 times pi times r squared. Now at GCSE level or even Key Stage 3, you're never going to get asked to how that formula is derived. So unlike a prism where you're working out the area of one face or one of the numerous faces or that are repeated in the shape and then just adding them together, with a sphere it's a little bit more difficult. So the context of how that formula is derived is not really important. You just kind of need to know that the surface area of a sphere is 4 times pi times the radius squared. Now again, if you're given the diameter, then you just need to make sure that you're halving that so you have the radius to then substitute that into the formula. Now the formula for a cone, this really depends on what part of the cone that you're looking for. So the total surface area, I should write here, so let me just quickly add that in. So the total surface area, and let me just quickly format that, and there we go, and then we just stick that in the center ish. So in terms of this, the total surface area consists of two parts. So one part is the base, which is this circle, which let me just do in a lighter color, which is this here. And we know that on a cone that's going to be a circle. It may be an ellipse, but that's never really going to be the case at this particular level. You only really deal with ellipses at A level, and even then it's not really covered. So the element of the base, which is this part of the formula here, so that this pi r squared is basically the base. Now for the curved area, that formula is pi r times L. Now L is the slanted length, so this is the curved area where r equals the radius and h is the perpendicular height and L is the slanted length. Now in some cases, as you may be able to spot, that we have a right angle triangle. So in some questions, which will be worth more marks, you may be given h and you may be given r, and to find L, what we can do is we can use Pythagoras. So to find L or even h and r, we can use Pythagoras, and that's something always to come in mind, particularly if you're working at a higher level. So just be mindful of that. Always make sure that you're reading a question carefully, because with a cone they might ask you for the total surface area or they might just look for the curved area, so just be mindful of reading the question carefully. So now let's put into practice using these formulas. So looking at question 1, it's asking us to find the surface area to 1 decimal place, and we've got spheres. Now here we don't need to worry about the total surface area because we're just going to assume that it is, but also that there's only really one face of a sphere, so it's going to be that. Now I always recommend students, when dealing with volume and surface area questions, to always start by first identifying what the shape is and then trying to write down what the formula is. So here we've got sphere for all these 3 questions, and we know that the formula is 4 times pi times r squared. So looking at for question A, we can see here that we've been given that the radius is 7. So all I need to do is to substitute it straight into the formula. So I've got 4 times pi times 7 squared, and if I work that out, so I've got 4 times 49, and I can either do that manually or by using a calculator, but I basically get 196 pi. Now this is the answer in terms of pi, so if it was on a non-calculator paper, this is what I would be writing. So this is the answer in terms of pi. And if you've got one of those Casio calculators, typing that all in, it'll give you the exact answer, which is this, and that is going to be in centimetre squared. Or I can write that as a decimal, which gives me an answer of 615.8, and that's in centimetre squared, and that's to 1 decimal place as requested in the question. So then moving on to B, exactly the same. So again, I write down what information I've been given. So I know the radius is 6. So then substituting it into the formula, I get the surface area equals 4 times pi times 6 squared. And then we just type that in. So 6 squared is 36. So 4 times 36 is 144. So it's 144 pi, and that's centimetre squared. And I need to convert that into a decimal. So I just type that into my calculator and I get an answer of 452.4, and that's centimetre squared to 1 decimal place. Then moving on to question C. So again, just double checking, I've been given the radius, not the diameter. So the radius is 2.6. So then the surface area is going to be 4 times pi times 2.6 squared. So 2.6 squared multiplied by 4 times pi gives me an answer of 84.9, and that's centimetre squared again. So if we move on to a hemisphere, so the question is asking us to find the total surface area of the hemisphere. Now we need to remember that with this particular shape, we've got two faces. We've got the base and we've got this curved part. What is going on? Let me just highlight that. So we've got these two parts that we need to be mindful of. So if I work out the curved area, and if it was a full circle, it would be 4 times pi times r squared. But because it's a hemisphere, I need to divide that by 2. So I can simplify that. We know that the radius is 8, so r equals 8. So I've got 4 times pi times 64 divided by 2. And if I type that in or work it out, whichever you prefer, we get 128 pi. Now I'm going to leave my answer as that because I've not quite finished, but if I wanted to, I could write that as a decimal, and that as a decimal is 402.1238, and it carries on with a few more decimals. Now with the base, so if we just write the base, well, that's going to be pi times r squared. So here it's going to be pi times 64, and so it's 64 pi. So then working out, and again I could write that, leave it as terms of pi, or I could write down the decimal equivalent, which is 201.061 blah blah blah. So then the total surface area are going to be those areas added up. So the total surface area is going to equal, well, this first one, which I'm just going to write in terms of pi because it gives me the exact value, plus the base, so 64 pi, and 128 plus 64 gives me 192 pi. So again, this is the answer in terms of pi. And if I wanted to work out the decimal equivalent of that, then it would be 603.2, and that's in centimetre squared, and that's been rounded to 1 decimal place. So now let's have a look at a cone. So here, let's just write down the formula again, just to remind ourselves. Now, if you are studying GCSE, you tend to find that these formulas will be given to you in the exam, but it's always good practice to know what they are. So we've got pi RL plus pi r squared. Now the question does ask for the total surface area, so it is going to include the base and that curved area as well. So looking at the first one, we know that R is 5 and we know that L is 9. And so looking at this, what we can then do is go straight into this formula, because the two letters I need are going to be R and L. So here the total surface area, well, let's just work out the two parts first. So let's just write down the base, which is pi times 5 squared, which is 25 pi. Then we've got the curved area, which is pi times 5 times 9, which is 45 pi. So then the total surface area is going to be 25 pi plus 45 pi, which is 70 pi. And if we convert that into a decimal to 2 decimal places, so 70 times pi, it gives me an answer of 219.91, and that's in centimetre squared. Then moving on to B. So again, here I've been given quite a lot of information. So here we've got that R equals 8. We've got H, which we don't need, but we do need that if we're working out the volume, is 15, and L is 17. Now because we're working with the cone and working with surface area, I need to know what L is. So from this diagram, as I mentioned earlier, that if we weren't given weren't given the slanted side, I could work that out by using Pythagoras. So I know that that's 15, the base is 8, so A and B are 15 and 8 respectively, and C is going to be the slanted side. So I could use Pythagoras to work out what that L value is, but in this question they've given it to me what it is. So here let's work out the base, which is pi times 8 squared, which is 64 pi. Then let's work out the curved area, which is going to be pi times 8 times 17, and 8 times 17 is 136, so it's 136 pi. So then the total surface area is going to be 64 pi plus 136 pi. So if it was on a non-calculator paper, you can see how, even though the shapes are quite complex, still easily we can write out the answer. So that's my answer in terms of pi, and if I type that into my calculator, I get an answer of 628.32, and that's centimetre squared, and that's to 2 decimal places. So moving on to question 4, it says find the total surface area of this cone to 2 decimal places. So again, let's write down the formula. So the surface area is equal to pi RL plus pi r squared. Now in this particular question, as you can see, we don't know what the L value is going to be, but if I turn this into a right angle triangle, label that as 12, I can work out that L squared equals 12 squared plus 3.5 squared. So L squared equals, and if I type that in, I've got 12 squared, which is 144, plus 3.5 squared, and I get an answer of 625 over 4. So therefore L is going to equal the square root of 625 over 4, and if I square root that answer, I get L equals 25 over 2, or 12.5. So then working with this, then I can then work out the total surface area. So it's going to be pi times r, which is 3.5, times the slanted area, which is 12.5, and I add that to the base of the cone, which is pi times 3.5 squared. Now again, what you might want to do is work this out separately, because otherwise you're trusting a lot in your calculator with BidMass to make sure it's typing it in correctly. So I get 175 over 4 pi plus 3.5 squared, which is 49 over 4 pi. And again, this question is most likely going to be a calculator, so you don't need to go too much into being concerned about what I've written on the screen. But it's just looking for exact values. So altogether that becomes 223 over 4 pi. And if I convert that into a decimal, which the question is asking me to, I get an answer of 175.14, and that's 2 centimetre squared as the units, and that's to 2 decimal places. So again, this is the answer in terms of pi. And again, how I've got 223 is just by simply adding the two numerators together because the denominators are the same. Now let's just have a quick look at reverse questions, because obviously these questions do come up and it's a case of just working backwards, and it kind of incorporates volume and surface area with solving equations. So again, remember that the surface area of a sphere is equal to 4 pi r squared. So this is the formula that we're going to be using. Now in these reverse questions, we've been given the surface area, but we need to work out what the radius is going to be. So for A, let me just do that over here so we've got a bit of space. So what we know is we've got 4 times pi times r squared equals 50. So what we need to get rid of is this 4 pi, and that's multiplying by r squared. So to get rid of it, we divide by 4 pi. So we've got r squared equals 50 divided by 4 pi, which gives me, and type that into my calculator, so 50 divided by 4, which is 12.5. So we've got 12.5 pi, and so r equals the square root of 12.5 pi. Now again, if your calculators work with decimals, that's absolutely fine. So I've got square root of 12.5 pi, and it gives me an answer of 6 point, and it's not telling me what I need to round it to, but 6.26 blah blah blah, and I can round that number up to 6.3 centimeters, and that's to 1 decimal place. So then moving on to B, let's just do that one. So again, very similar. So what we've got is we've got 4 pi r squared equals 940. So then r squared equals 940 divided by 4 pi. And if I type that all into my calculator in one go, so divided by 4 pi, I get r squared equals 74.802. And then if I just simply square root that value, I get 8.65 centimeters, and that's to 2 decimal places. And then for C, we've got and just draw a little line there. So we've got 4 pi r squared equals 4,800. Now recognizing that x here is the diameter. So again, we just need to make sure we're doing that. So here we've got r squared equals 48,000 divided by 4 pi. So r squared equals, and just type that in quickly into the calculator, and I get an answer of 3,819.71, and then a few decimals there. So r equals the square root of that answer, which is 61.803. And so x equals, remember x is the diameter, which is basically 2r, is going to be that number times by 2, which gives me an answer of 123.6 or 61 I should say centimeters, and that's been rounded up to 2 decimal places. So now let's have a look at some more reverse questions, this time related to a cone. So let's just write down the formula. So the cone is pi r L plus pi r squared, and that equals the surface area. So in looking at A, the question is asking us to work out L. So from this, what we know is we know that pi times r times L plus pi r squared equals 216 pi. So even though the surface area is given to me in terms of pi, that's not really a problem. It just means that it could be on a calculator or a non-calculator paper. Now, R we know is 9, and L is what we're trying to find, and L equals X. So substituting the values that we know, so what we've got is pi R, which is 9 pi, so 9 pi L plus 81 pi equals 216 pi. So 9 pi L equals 216 minus 81, which gives me an answer of 135. And then from this, I can cancel the pi's out. So I'm left with 9L equals 135. So then L equals 135 divided by 9, and 135 divided by 9 gives me an answer of 15 centimeters. Then working with B, let's choose a different color. So with B, substituting numbers in the formula, I get pi times, what R is 11. So I've got 11 pi L plus 121 pi equals 792 pi. Now at this stage, because everything's got a pi, I can cancel that out. So then what I've got is I've got 11L plus 121 equals 792. And as you can see, it's turned into a linear equation in which I can swap L with X, because what you don't want to do is get confused with making your L's look like a 1. So then from this I get 11X equals 792, take away 121, which is 671. So X equals 671 divided by 11, which gives me an answer of 61, and that's centimeters. And there is my answer for that one. So moving on to example 3, this question, again, we're given a cone and the question is asking us to find the radius. Now this one's a little bit tricky and probably more likely to be a GCSE high level question, and the reasons for that will be explained as we go on. So here we're given the surface area in terms of pi. So the first thing that's always important is to write down the formula that we know we're going to have to use. So the surface area of a cone, or the total surface area I should write, is going to be pi RL plus pi R squared. So this is the formula I'm going to be using. So looking at the information I've been given, well, I know that L equals 5 and the surface area is 36 pi. So then substituting all of those bits of information, what I end up with is pi times R times 5 plus pi times R squared equals 36 pi. Now just in neating all of this up, I can write this as 5 pi R plus pi R squared equals 36 pi. Now you might be thinking to yourself, well, how do I go on to solve this? Might potentially looking at factorising left hand side, but actually it's a little bit more simpler than that. So here we notice that every single term has got pi, so I can divide both sides by pi. Let me choose a different colour so it's a bit more obvious of what I'm actually doing. So what I'm left with is 5r plus r squared equals 36. Now hopefully you're spotting that this now is starting to look like a quadratic equation. So from this, when solving a quadratic equation, we want to make it equal to 0. So we've got r squared plus 5r minus 36 equals 0. And then solving the quadratic, we can either factorise or we can use the quadratic formula. So does this factorise? Well, looking at 36, well, the numbers I can use are 1 and 36, 2 and 18, 3 and 12. We've got 4 and 9, and we've got 6 and 6. So using these, how many of these can I make 5? Well, I can use 5 by using those two. So it does factorise, in which I've got 4 minus 9, and plus 9, and it's going to be r minus 4 equals 0. So radius equals minus 9 or 4. Now we can't have negative length, so it can't equal -9, so r equals 4, and there is my answer. So now moving on to our final example of a reverse question. It says find the height of this cone. So let's first of all start by writing down the information that we know. So we know that the radius is 16, we know that the height is x, and we know that the surface area is 800 pi. So with this question, what we need to do is first of all work out L. And we do that by using Pythagoras. So looking at this, if I just label this L, then we know that L squared equals 16 squared plus x squared. So then what we've then got is that L squared equals 256 x squared. And so L is going to equal the square root of this, in which it does square root. So the square root of 256 is 16. So it's going to be 16, and the square root of x squared is x. So L equals 16x. So let me just put a little bubble around that. And we can add this to our information that we've been given. So L equals 16x. So then if I refer to the total surface area of a cone, it equals, I'm going to write in the reverse order, so we've got pi RL plus pi r squared equals SA. So then substituting all the variables in, I'll put in brackets, so we've got pi times r, which is 16, times L, which is 16x, plus, and then we've got pi r squared, so that's going to be pi times 16 squared, and that all equals 800 pi. So then simplifying each of these brackets, so this bracket here then becomes 256 pi, and this becomes 256 pi, or the 256x I should say, because I knew there was something missing there. So let me just write that out again. So we've got 256x, or pi x. Doesn't really matter if you wrote it the other way around, and this is going to be 256 pi equals 800 pi. So again, what we can do is we can cancel out the pi's, because everything's got a pi, and what we've got is 256 256x plus 256 equals 800. Now I've only got one variable, there's no square in there, so I can just go on and solve this as I would a linear equation. And so what we've got from here is 256x equals 800 minus 256, which is 544. And so x equals 544 divided by 256. So x equals, and it gives me an answer of 2.125, and that's in centimetres, and there is my final answer.